Welcome to this explainer. Look, if you're a technical executive or a software developer trying to map out your long-term strategy, this is the architectural blueprint you absolutely need. Right now, we're witnessing a massive, fundamental, industry-wide transition. We are moving away from generative chat interfaces and diving headfirst into the era of asynchronous agentic runtimes. And to really understand it, we need to structurally analyze the monumental shifts that happened across the AI ecosystem during one highly critical week, May 17th to 24th, 2026. Here's our blueprint for today. We're going to sequentially examine 1. OpenAI's verifiable enterprise reasoning. 2. Google DeepMind's runtimes and edge mo. 3. Anthropic's autonomous cyber weaponization. 4. Meta's restructuring for scale. 5. NVIDIA forcing the hardware refresh cycle. And finally, 6. We'll wrap up with the macro ecosystem strategic outlook. It is actually wild to think about the sheer density of infrastructure announcements deployed in just this one single week. I mean, from Google's runtime reveals all the way to OpenAI's deep reasoning breakthroughs, this timeline sets a completely new standard for the enterprise ecosystem. So let's break down exactly what happened. Starting with part 1, OpenAI and verifiable enterprise reasoning. To really grasp OpenAI's strategic shift away from just brute force parameter scaling, we have to look at their May 20th announcement regarding the Erdős planar unit distance conjecture. Now, this is an 80-year-old mathematical problem. You might remember OpenAI had an embarrassing incident in late 2025 where a previous model basically just regurgitated memorized math literature. Well, to reclaim their scientific credibility, they deployed an internal reasoning model that autonomously generated a verifiable, totally novel counterexample to this conjecture using advanced number theory. It didn't use heuristic shortcuts. It originated genuinely novel mathematical constructions that top human mathematicians are now validating. But here's the crucial takeaway for us. Alongside these deep reasoning breakthroughs, OpenAI aggressively restructured their commercial endpoints. They are heavily prioritizing regulated enterprise privacy. They launched the Secure MCP tunnel, which means corporate clients can connect to on-premises servers with absolutely zero public internet exposure. They also cleaned house on legacy models, deprecating DALL-E 2 and 3 for ChatGPT Images 2.0, complete with durable synthide watermarking and C2PA conformance. The focus here is crystal clear: deep, academic reasoning, entirely wrapped in highly secure, verifiable enterprise infrastructure. Moving into part 2, Google DeepMind. Runtimes and edge MOE. Over at Google, their developer conference functioned as a sweeping delivery of an AI stock entirely dedicated to one thing: eradicating latency. They're tackling a core computer science limitation head-on, Amdahl's law. Think about it. If an AI agent spends half its time waiting on a slow, external legacy database, your entire system speed is bottlenecked, regardless of how fast the AI generates text. So to solve this, Google's Antigravity 2.0 runtime autonomously rewrote internal Python tools into the Go language. We are talking about achieving 10x to 20x speedups for background agent execution. They are fundamentally redesigning tools for machine-paced rather than human-paced interaction. To power these rapid environments, Google positioned Gemini 3.5 Flash as their flagship ecosystem model, and it performs aggressively well on agentic coding and multimodal tasks, running at blistering speeds of over 550 tokens per second. But it's not all perfect. Developers are definitely noting a severe cost friction here, sometimes costing over $1,000 for exhaustive benchmark runs. And compared to specialized reasoning models, it can struggle a bit with deep system design workloads. But here is where Google really flexed its architectural muscle. In the open weight space, they released Gemma 4. Now, out of its 25.2 billion total parameters, this mixture of experts model activates only 3.8 billion parameters per token during inference. This is a huge deal. It achieves 97% of the quality of dense models using merely 12% of the compute. They are essentially democratizing MOE architectures for highly constrained edge deployments. All right, part 3, Anthropic and autonomous cyber weaponization. So, if OpenAI dominated mathematical reasoning and Google defined the edge runtime, our third player, Anthropic, has entirely monopolized the cybersecurity paradigm. Through an initiative called Project Glasswing, Anthropic deployed their Claude Mythos Preview model to scan systemic internet infrastructure, working alongside partners like AWS and CrowdStrike. The model flagged an astonishing 23,019 security findings in open-source projects in just weeks. Over 1,500 of those were fully validated as critical vulnerabilities. The paradigm has flipped. The bottleneck is no longer vulnerability discovery, it is entirely constrained by our human capacity to patch them. And when you look at the rigorous exploit bench, which targets the heavily defended V8 JavaScript engine, you really see Anthropic's massive capability overhang in offensive cyber operations. Anthropic's model achieved Tier 1 arbitrary code execution on 21 out of 41 vulnerabilities. OpenAI's GPT 5.5, it managed only 2. Anthropic's system is autonomously reverse engineering complex random number generators and outright bypassing kernel-level defenses. This isn't just a benchmark win, it is a profound institutional threat that is actively forcing a defensive shift across the ecosystem. That brings us to part 4, Meta, and their restructuring for scale. We are seeing a completely different tactical approach over at Meta. They are basically brute forcing their way into the agentic era. Mark Zuckerberg has aggressively accelerated Meta's transition into an AI-first infrastructure company. And to do that, he raised their 2026 capital expenditure to a staggering maximum of $135 billion. To support this massive pivot, they initiated a pretty draconian workforce reorganization. They shifted thousands of engineers into AI cloud infrastructure and onto an internal agent codenamed Hatch. And get this, to train these agents, Meta even launched internal surveillance tools to track employee keystrokes and mouse movements, all just to gather high-fidelity human-computer interaction data. Now, commercially, their open-weight strategy remains an absolute force. They deployed Llama 4 Scout with a highly optimized mixture of experts architecture and a massive 10 million token context window. However, behind the scenes, things are a bit rocky. Their proprietary next-generation frontier model, codenamed Avocado, is facing severe delays. It's struggling against frontier benchmarks, which has actually prompted Meta executives to explore temporarily licensing Google's Gemini models to power internal products as a stopgap. Next up, Part 5, NVIDIA, forcing the hardware refresh cycle. Of course, none of these incredibly complex software architectures mean anything without physical hardware. Preempting all the major trade shows, NVIDIA unveiled their next-generation platform, codenamed Rubin. Fabricated on a 3-nanometer process, Rubin delivers a literal quantum leap in computational density. It is engineered to push baseline performance from the 20 petaflops we saw with the previous Blackwell architecture all the way up to 50 and eventually 100 petaflops with Rubin Ultra. NVIDIA isn't just updating hardware, they are forcing a massive hardware refresh cycle by shifting the entire industry into a highly complex 6-chip ecosystem. Armed with an effortless $81.62 billion in quarterly revenue, NVIDIA knows that the true bottlenecks moving forward aren't just in silicon. They are in physical interconnects and power. So they aggressively moved to secure the entire supply chain. They poured billions into Luminum and Corning for optical connectivity and partnered with Iron to lock down 5 gigawatts of dedicated AI energy infrastructure. NVIDIA is heavily fortifying the inescapable physical bedrock of this entire industry. Finally, Part 6, the macro ecosystem strategic outlook. So, synthesizing all of these massive corporate movements, the overarching intelligence frontier is visibly bifurcating. On one hand, you have OpenAI's deep focus on rigorous academic reasoning and scientific validation. On the other hand, we see Google and Meta hyper-focused on low-latency, real-world agentic action. What's also clear is that the efficiency race is now entirely governed by mixture of experts' architectures. Models are activating only a fraction of their parameters to absolutely maximize compute-to-quality ratios at the edge. But simultaneously, we're watching the militarization of code generation unfold in real time. Anthropic definitively proved that autonomous cyber capabilities can easily and quickly overwhelm human patching bandwidth. And this is forcing a massive defensive ecosystem shift. Enterprises are actively being driven away from cloud dependency, where their data is highly vulnerable, and pushed towards secure, zero-trust, edge-localized architectures, much like the air-gapped workstations we just saw announced by Dell and NVIDIA. Which brings us to the ultimate strategic dilemma for any technical executive analyzing this blueprint today. We are officially leaving the chat interface era. We are entering a domain of asynchronous execution, extreme hardware demands, and incredibly potent autonomous cyber threats. The models are reasoning, the agents are acting, and the physical infrastructure is being rapidly locked down. So as this entire global ecosystem rebalances itself, where exactly does your enterprise stack reside? Keep analyzing, and we'll see you in the next explainer.